So now that we've heard of the term mole before, which is a big number, right? Avogadro's number, and so we know that 1 mole of anything is 6.02 times 10 to the 23rd of that thing. And this can be anything. This can be, oh, I don't know, autographed pictures of Justin Bieber or Bo Jackson bobbleheads. It can be anything. In our case, we are talking about atoms. And if you recall, we used it by taking this value for atomic mass and turning it into molar mass. And so we know that 1 mole of carbon, that's 12 grams. So if you have 12 grams, you have a mole. And if you have a mole, you have 6.02 times 10 to the 23rd atoms. Well, we're going to take this a step at a time. So what we're going to do is we're going to say, well, here's a question you can expect me to ask. So let's take this question. It's asking for how many atoms of tungsten are in 5 moles of tungsten. So we always want to establish what we're looking for and what they give us, because this is how we're going to construct our conversion factor. So we're going to ask how many atoms of tungsten are the equivalent of 5 moles of tungsten. And this is where our conversion factor comes in. Remember that what we want goes on the top. What we have goes on the bottom. In this case, we know that the equivalent is 6.02 times 10 to the 23rd atoms anytime we have a mole. So let's bust out our calculator. So our calculator's here, and what we're going to do is we are going to multiply across the top and divide by the bottom. And what that means is we're going to take 5 and we're going to multiply this by 6.02 times 10 to the 23rd. Now, I may have reminded you of this earlier, but let me say it very clearly again. The way we want to enter our exponents is with this function, exponent entry. We don't want to use this. So we're going to say 6.02. We're going to hit second. We're going to hit exponent entry. And that little E lights up. That is the calculator's way of saying times 10 to the 23rd. Now it treats this as one solid number. And then we'll divide it by 1. Here's how many atoms of tungsten are in 5 moles. 3.01 times 10 to the 24th atoms. If we did it in the other way, let's see if we get anything different. 5 times 6.02 times 10 to the 23rd divided by 1. See what happens? If we do it like this, your calculator has a hard time discerning. All right? So we want to make sure that when we're entering our exponents, we're using the exponent entry function. And I'll tell you what, that if you do it the other way, your answers will be right 90% of the time. But 10% of the time, they won't be. All right, let's do one more. All right, this time we're going the other way. We're looking for moles. We're starting with atoms. So we're going to ask how many moles of neon would be the equivalent of 3 times 10 to the 19th atoms So our conversion factor is going to look like this. Atoms of neon is going to go on the bottom because that's what we got. Moles of neon is going to go on the top because that's what we want. And 1 mole of anything, there are 6.02 times 10 to the 23rd. Atoms, of course, cancel. Leaves our answer in moles. Let's bust out our calculator. We're going to say 3 times 10 to the 19th. We're going to multiply this by 1, even though it's not necessary. And then we're going to divide it by 6.02 times 10 to the 23rd. Now, before I hit a button on my calculator, Before I hit a button on my calculator, it's a good idea to try to predict what we think our answer is going to be, because that's not a mole's worth. That's quite a bit less. In fact, it's about 10,000 times less than a mole's worth. So I'm going to predict my answer is going to be somewhere in the neighborhood of 0.0001. In fact, even less than that, because 3 is half of 6. So we're expecting an answer that's a decimal, about 4 decimal places. All right, so let's hit our answer and see if it jibes with what we expect. And that's pretty close. All right, we said 0.0001. Less than that is 0.00005. Here's our answer. 5, let's get rid of this. 5 times 10 to the negative 5th. If you want to write that out in long form, 0.00005. 1, 2, 3, 4, 5 decimal places. Moles of neon. Okay. See you on the next one.